In the beginning, before the first atoms had cooled, before the first star carved its brilliance into the dark, the universe was a silent ocean of potential, an infinite expanse waiting to decide what it would become. And even now, after 13.8 billion years of cosmic evolution, after galaxies have spun themselves into spirals and clusters have formed webs of impossible scale, the cosmos still feels like a riddle written in a language no human fully understands. It speaks in gravity, whispers in starlight, and hides its deepest truths in the vast, cold spaces between galaxies. To explore the universe is to explore a place where emptiness is never truly empty, where darkness is never quite dark, and where every photon carries a fragment of a story older than time itself. When we gaze upward at night, the sky seems peaceful, even gentle, a quiet dome studded with patient stars. But this serenity is an illusion caused by distance. The cosmos is anything but calm. Stars explode with the force of billions of nuclear bombs. Black holes tear apart suns as if they were dust motes. Galaxies collide in slow-motion cosmic avalanches. Invisible forces shape everything we see, yet evade every telescope we build. To understand the universe is to confront the unknown in its purest form, to stretch our fragile minds across distances too vast to imagine. And yet, something within us insists on trying. Perhaps it's encoded in our biology, in the same spark that pushed our ancestors to cross oceans and mountains. Or perhaps it's older than that, something cosmic, a memory from the atoms we are made of. After all, every carbon atom in your body was forged inside a star that died billions of years before Earth was born. The universe created us, and maybe, on some level, we remember. But the universe does not give up its secrets easily. Its most profound mysteries hide not in the brilliant glow of galaxies, but in the shadows between them. It hides in the cold, silent voids that stretch for hundreds of millions of light years. It hides in particles that pass through your body by the trillions each second, yet leave no trace. It hides in the edges of physics, where space seems to fold into itself and time loses meaning. These mysteries are the reason scientists stare into the abyss with enormous telescopes, hoping to catch a glimpse of something that refuses to be seen. One of the most haunting puzzles of the cosmos lies in something we cannot touch, cannot see, and cannot directly detect, yet it outweighs everything familiar. Dark matter. To imagine the universe without it is to imagine a cathedral without pillars. Galaxies would not hold together. Stars would drift into the darkness. The elegant structure of the cosmic web would crumble into chaos. Something is binding the universe in place, sculpting its form, guiding its evolution. But what? For nearly a century, scientists have hunted this invisible scaffolding, searching through deep underground detectors, studying the motions of galaxies, scanning the cosmos for faint signals of exotic particles. And yet, the nature of dark matter remains elusive. It is matter that behaves like a ghost, shaping the cosmos without ever revealing its face. The mystery deepens when we consider dark energy, the force that drives the accelerating expansion of the universe. If dark matter is the silent architect holding galaxies together, dark energy is the cosmic wind tearing them apart. It makes up nearly 70% of the universe, yet no one knows what it is. Its discovery in 1998 stunned astronomers. The universe wasn't slowing down, as logic suggested. It was speeding up, as if some unseen pressure was stretching space itself. Even today, dark energy remains one of the most profound enigmas in science. It is not just a missing piece of the puzzle, it is the puzzle. Sometimes to search for answers, scientists look toward darkness. Other times, they look toward light, analyzing the glow of distant stars, measuring the faint afterglow of the Big Bang, or peering into the atmospheres of exoplanets. Light is the oldest traveler in the universe. It has crossed unimaginable distances to reach us, carrying with it hints of what lies beyond our reach. Every photon that enters a telescope is a messenger from the past. Some left their stars when Earth was forming. Others began their journey before any life existed on our planet. When we intercept that ancient light, we are not just observing the cosmos, we are reading a billion-year-old diary. But not all mysteries come from what we can see. Some come from what we hear, or rather, what space allows us to hear. In 2015, humanity detected gravitational waves for the first time, ripples in the very fabric of space-time. Predicted by Einstein a century earlier, they were the result of two black holes merging over 1 billion years ago. These waves traveled across the cosmic ocean, passing through galaxies, voids, clusters, superclusters, and cold expanses of nothingness to finally brush past Earth. In that moment, we heard the universe not in light, but in motion. For the first time, we listened to the cosmos breathe. This breakthrough opened an entirely new method of exploration. We could now hear collisions of dead stars, black hole mergers, and perhaps someday signals from events so extreme that no light escapes them. Space-time itself had become an instrument, vibrating with the echoes of cosmic catastrophes. And yet even these waves tell us only fragments of a larger, deeper story. The story becomes even stranger when we look at voids, the vast regions of almost nothing that make up most of the universe. These are not empty spaces but cosmic deserts, places so large that entire superclusters could fit inside them with room to spare. The Bootes Void, one of the largest known, spans 330 million light-years. If our galaxy were drifting inside it, the night sky would be nearly starless. Instead of a glittering tapestry of light, we would see only a handful of distant, lonely points. We may have never discovered that other galaxies existed. We would have believed the universe was a dark, silent place, and that we were utterly alone. These voids are not random. They are shaped by dark matter, cosmic inflation, and gravitational flows that began seconds after the Big Bang. They are part of the cosmic web, the universe's grand architecture. To visualize it is to imagine a spider web made of galaxies instead of silk, stretching across unimaginable distances. Where the strands intersect, galaxy clusters form. Where the strands thin, voids emerge. The web is not static. It is alive with the slow dance of matter, shaped by forces we barely understand. But the universe has deeper mysteries still. Some hide in the quantum realm, where particles behave like waves, disappearing and reappearing, entangling across vast distances, defying logic. Others hide in the event horizons of black holes, where information seems to vanish. Others hide in the early moments of creation, when the universe expanded faster than light in a fraction of a second, imprinting patterns on a cosmic scale that we still struggle to decipher. And some mysteries may be life itself. For the first time in history, telescopes like the James Webb Space Telescope can analyze the atmospheres of distant planets, searching for chemical fingerprints that hint at biology. Methane, oxygen, water vapor, dimethyl sulfide, molecules that on Earth are tied to life. With every new exoplanet discovered, the question grows more urgent. Are we the only living world in an otherwise silent universe? Or are we one of countless civilizations scattered among the stars? And if life is common, why have we never heard from anyone? The silence of the cosmos is not comforting, it is deafening. Some believe we stand at the edge of a great discovery. Others believe we stand at the edge of a great danger. Because the universe is not empty. It is filled with radiation, wandering black holes, rogue planets, supernova remnants, cosmic rays that pierce through flesh and bone. It is filled with forces that could destroy us without warning. And yet, despite this cosmic hostility, we look into the abyss with fascination instead of fear. Perhaps that is humanity's true strength, our desire to understand, even when understanding terrifies us. We search the void not because it is safe, but because it is unknown. We send telescopes into the cold, observatories into the desert, and probes into the darkness between worlds because something inside us refuses to be confined to one planet. The same instinct that pushed life from the oceans onto land, that pushed humanity out of Africa, now pushes us into the stars. The cosmos is not just a place, it is a story we are only beginning to read. And the deeper we go, the stranger it becomes. The deeper we travel into the cosmic abyss, the more we begin to realize that the universe is not just vast. It is layered. It is a tapestry woven from threads of energy, matter, and laws so subtle that even our most advanced instruments are only beginning to trace their outlines. The more knowledge we gather, the more mysteries rise behind it like mountains behind fog. The universe expands not only in size but in complexity, and each step toward understanding reveals horizons that stretch even farther away. Take black holes, for example. These are the darkest objects in existence, so dark that not even light escapes their pull. Yet the closer we look, the more they defy comprehension. Once thought to be simple gravitational traps, they are now understood to be cosmic engines, shaping galaxies, altering space-time, and possibly forging the seeds of new cosmic structures. At their centers lies a singularity, a point of infinite density, where the laws of physics unravel, where time itself may fold, loop, or cease to exist. It is impossible to imagine anything more alien, yet black holes may be among the most common endpoints of matter in the universe. Even stranger is the possibility that black holes might store information. According to quantum mechanics, information cannot be destroyed. But if something falls into a black hole, an atom, a planet, a star, where does the information go? Is it smeared across the event horizon as quantum hair? Does it leak out slowly through Hawking radiation? Or does it slip into another region of space-time entirely? The information paradox has consumed the greatest minds in physics, from Hawking to Susskind, suggesting that black holes may be gateways not to destruction, but transformation. But mysteries are not confined to massive objects. Some lie in the smallest particles, in the quantum foam that exists at unimaginably tiny scales. The vacuum of space is not empty. It boils with virtual particles popping in and out of existence, borrowing energy from the quantum field and vanishing again. The entire universe is built atop this restless sea of nothingness, a simmering foundation beneath the stars. Some theories propose that this quantum foam is responsible for dark energy. Others claim it may be evidence that space-time itself is granular, like pixels on a screen. If true, then reality is not continuous, but quantized, built from discrete units so small that even photons are giants by comparison. The quantum realm is a paradoxical domain where a particle can be in multiple places at once, where two particles can become entangled and share information instantly across any distance. Einstein famously called this spooky action at a distance, but experiments confirm its reality. Entanglement is not merely a weird trick of physics. It may be a fundamental feature of the universe, a hidden network binding everything together beyond the speed of light. Some physicists even argue that space-time itself emerges from a vast web of quantum entanglement. In this view, reality is not made of particles, but of relationships. Space, time, matter, everything may arise from the invisible bonds between quantum systems. This idea leads to one of the most breathtaking possibilities. The universe is not a place, but a process. It is not constructed from objects. It is constructed from interactions. And consciousness, our ability to perceive and reflect, may be another emergent phenomenon arising from this cosmic network. Perhaps the universe is observing itself through us, experiencing its own evolution through the eyes of the beings it created. As we look outward, we inevitably look inward. But the cosmos is not only a realm of physics, it is a realm of origins. The question of how life begins is just as profound as the question of how galaxies form. And here, too, the universe keeps its secrets close. Life on Earth emerged quickly, within a few 100 million years of the planet cooling. This speed suggests life may be a natural outcome when conditions are right. Yet in all our searching, on Mars, in Venus's clouds, in Europa's ocean, in Enceladus's plumes, we have not found definitive proof of life anywhere else. This contradiction sits at the heart of the Fermi paradox. If life arises easily, why don't we see it everywhere? One possibility is that life is common but primitive. Microbial ecosystems might flourish beneath the ice of distant moons or within the oceans of exoplanets, but never evolve intelligence. Another possibility is that intelligent life is common but ephemeral, a brief candle extinguished by self-destruction, climate collapse, cosmic catastrophe, or simple bad luck. Civilizations may arise, shine, and vanish long before they have time to explore the galaxy. In this view, the silence of the universe is not a sign of emptiness, but of fragility. Yet another possibility is that intelligent life is everywhere, but not in forms we would recognize. Perhaps they are artificial intelligences, having transcended biology entirely. Perhaps they exist as energy-based entities, or live inside megastructures built around stars. Or perhaps they evolved in environments so unlike our own, ammonia oceans, methane atmospheres, plasma clouds, that communication with them is nearly impossible. If their senses, languages, or dimensions differ from ours, then their presence could surround us even now, unnoticed and undetectable. In this view, the universe is not silent. We simply lack the right ears. Even stranger is the possibility that advanced civilizations deliberately avoid contact. If most intelligent species adopt a cosmic quarantine policy, choosing observation over interference, then Earth may be located inside a vast interstellar nature preserve. Perhaps we are like insects in a protected forest, studied, watched, but never disturbed. As unsettling as these ideas may be, they cannot be dismissed. The more we learn about the cosmos, the more we recognize the limits of our understanding. And yet humanity continues its ascent. Telescopes like JWST, the Vera Rubin Observatory, and the upcoming Roman Space Telescope are opening new pathways. We are detecting planets the size of Earth orbiting stars hundreds of light years away. We are studying their atmospheres, mapping their temperatures, measuring their clouds. We are listening for radio signals that may never come, yet we persist. The universe is a puzzle with infinite pieces, and our curiosity is relentless. Perhaps this curiosity is itself cosmic. The atoms in our brains were forged in ancient supernovae. The iron in our blood was created in the collapse of a giant star. The calcium in our bones was born in the death throes of massive suns. We are the cosmos made conscious, the universe awakening to itself. When we stare at the night sky, we are not looking at something separate. We are looking at our own origin. But origins are only one side of the equation. The other is destiny. What fate awaits the universe? Current evidence suggests expansion will continue indefinitely. Galaxies will drift farther apart. Stars will burn out. Black holes will evaporate. Over unimaginable stretches of time, matter itself may decay. The cosmos may fade into darkness, a cold, quiet, eternal night known as heat death. In this distant future, entropy wins. Order gives way to chaos. Structure dissolves. The last photons stretch into oblivion, and the universe becomes a featureless void once again. Unless, of course, we are wrong. Perhaps dark energy will change over time, reversing the expansion and causing a big crunch. Perhaps quantum fluctuations will trigger new universes, branching off like cosmic bubbles. Perhaps black holes are engines of creation, spawning new regions of space-time. In this view, our universe is just one of countless realms in an infinite multiverse, a cosmic archipelago where every possible reality exists somewhere. If this is true, then the mysteries we observe may not be anomalies, but variations. The cosmic voids may be scars of ancient collisions between universes. Dark matter may be gravity bleeding through from parallel dimensions. Quantum entanglement may be a sign that space is not local, but part of a larger, interwoven structure. Even consciousness may be a universal phenomenon, arising wherever complexity allows. In the end, the greatest mystery of the universe may be that it exists at all. Why should there be something instead of nothing? Why should the laws of physics be so precise, so balanced, so exquisitely tuned that stars can shine, planets can form, and life can emerge? Perhaps the answer is simple. If the universe were any different, we would not be here to ask the question. But that explanation feels too cold, too mathematical for a cosmos filled with such wonder. There must be deeper meaning, if not in purpose, then in experience. The universe is not just expanding, it is unfolding, evolving, revealing. And humanity, though small, is part of that revelation. We are the observers, the storytellers, the seekers. The cosmos does not need meaning, but we do. And in searching for it, we give meaning to ourselves. The night sky above us is not a void. It is a vast ocean of time, memory, and possibility. Every star is a lighthouse. Every galaxy is a chapter. Every mystery is an invitation. And our journey has only just begun. As we push farther beyond the edge of the familiar, the universe becomes a mirror, reflecting not only its own enigmas, but the mysteries within ourselves. The more the cosmos reveals, the more we realize we are still standing at the shoreline of an infinite ocean. Every answer births new questions, each more intricate, more ambitious, more humbling. One of the most haunting cosmic puzzles lies in the nature of time itself. We move through time so effortlessly that we forget it may not be fundamental at all. Some physicists argue that time is emergent, not a basic ingredient of the universe, but a side effect of entropy increasing. In other words, time may flow because disorder grows. If entropy were to decrease, time might reverse. And in the quantum realm, where particles can move backward and forward in time, the arrow of time might dissolve entirely. This suggests a strange possibility. The universe may not evolve from past to future the way we perceive it. Past, present, and future could all coexist in a vast, static structure, a timeless, cosmic block. Our consciousness may simply be sliding along this structure like a beam of light passing across a sculpture. Reality might not be happening. It might simply be. If this is true, then the birth of the universe, the Big Bang, takes on a different meaning. It is not the beginning of everything, but one point in an eternal landscape. The Big Bang becomes a boundary in space-time, not a moment of creation. Some theories even propose that before the Big Bang, there was another universe contracting into collapse. The bounce between destruction and creation could be eternal. This cyclical vision aligns with ancient myths that described cosmic rebirth long before modern physics existed. Perhaps our ancestors sensed in symbolic form what mathematics now whispers, that the universe may rise and fall endlessly, with each iteration rewriting the stars. Yet even this model cannot answer the ultimate question. Why does the universe obey laws that allow complexity? Why does matter form galaxies rather than dispersing as a uniform mist? Why does chemistry emerge, stacking atoms into molecules, molecules into cells, cells into consciousness? This is where the fine-tuning problem enters. The constants of physics, gravity, electromagnetism, the masses of particles, the strength of nuclear forces, are balanced with near impossible precision. A slight shift in any one of them would make stars unable to form, atoms unstable, or life outright impossible. Some scientists call this coincidence, others call it inevitability, and still others propose something astonishing, that fine-tuning is an illusion, because our universe is one of countless universes, each with different laws. In the multiverse, every combination of physical laws laws exist somewhere. Most universes are sterile. A few, like ours, are capable of life. We exist in a universe suited for life not because it was designed for us, but because only in such a universe could life evolve to notice the design. This idea, called the anthropic principle, is both elegant and unsettling. It suggests that meaning may not lie in the universe itself, but in our ability to perceive it. As we wrestle with these questions, our telescopes keep uncovering new wonders. Consider the cosmic voids, the dark, monolithic spaces between galactic filaments. Once thought to be empty, these voids now appear to be rich in dark energy, the mysterious force accelerating cosmic expansion. If dark energy dominates these regions, then voids are not the least interesting parts of the universe. They are the engines driving its growth. One theory proposes that dark energy could fluctuate over time, becoming stronger or weaker. If it strengthens, the expansion of the universe will accelerate until galaxies disappear beyond the cosmic horizon, leaving each in isolation. Stars will die alone, unobserved. If it weakens, gravity may regain dominance, pulling galaxies together again. Cataclysmic collisions could reshape the cosmic landscape. The future of everything depends on a force we cannot see, measure directly, or fully understand. And what of the galaxies themselves? They are not eternal. The Milky Way is on a collision course with Andromeda, a dance set to unfold over billions of years. When they merge, new stars will ignite. Black holes will collide with unimaginable power. Entire star systems may be flung into intergalactic space. Yet amid this chaos, new worlds may be born. Cosmic destruction and creation are inseparable. The universe is not static. It is alive with motion. Galaxy clusters drift through the cosmic web, pulled by invisible rivers of dark matter. Some regions move faster than others. In the Great Attractor, an immense gravitational anomaly, galaxies, including our own, are being drawn toward an unseen mass. Even more baffling is the Shapley supercluster, another colossal region influencing the flow of galaxies. We are not just orbiting the Sun or the galaxy. We are drifting through cosmic currents shaped by structures hundreds of millions of light years away. This raises a profound question. What else is out there beyond the edge of the observable universe? Our telescopes can only see so far because the speed of light is finite. Beyond that horizon may lie structures larger than anything we can imagine, superclusters, voids, or even the boundary between universes. The cosmos we observe may be only a tiny island in a vast archipelago of infinite worlds. But the most intimate mysteries are closer to home. Consider consciousness. How does the universe produce beings capable of asking where they come from? How do atoms, forged in stars, assemble into minds that dream, question, and yearn? Some scientists argue consciousness is an emergent property of complexity. Others believe it is fundamental, a basic feature of reality like space and time. If consciousness is woven into the fabric of the cosmos, then life is not an accident, but a natural expression of the universe waking up. Even more provocative is the idea that consciousness and quantum mechanics are linked. In some interpretations, consciousness collapses the wave function, selecting a single outcome from many possibilities. If true, then the act of observation is not passive. It participates in creating reality. We become co-authors of the universe, not merely spectators. This idea extends to one of the most astonishing theories ever proposed, that reality may be holographic. According to the holographic principle, everything in our 3D universe may be encoded on a 2D surface at the boundary of space-time. We experience a three-dimensional world, but its underlying information may be stored on a far-distant cosmic horizon. In this scenario, our universe is a projection, an extraordinary illusion rendered by the laws of physics. And yet, whether the universe is holographic, quantum, multiversal, or something beyond our imagination, one truth remains. The mysteries deepen as we approach them. Knowledge does not shrink the unknown, it expands it. We have mapped less than 5% of the cosmos. We do not know what dark matter is. We do not know what dark energy is. We do not know how consciousness arises. We do not know if we are alone. These are not failures. They are the greatest opportunities for discovery in human history. Humanity stands at the dawn of a new cosmic age. We have the tools not just to observe, but to understand. JWST is only the beginning. Future missions like LUVOIR, HABEX, and the Einstein telescope will push our vision even farther. We may soon detect the atmospheres of truly Earth-like worlds, capturing molecules that hint at photosynthesis or metabolism. We may hear the faint echoes of alien technology in the radio spectrum. We may watch black holes merge, illuminating hidden features of space-time. And beyond that lies an even greater frontier, interstellar travel. Today it seems impossible. But so once did electricity, flight, space travel. Technologies like nuclear fusion, antimatter propulsion, and light sails may one day carry us across the stars. Humanity might spread through the galaxy, becoming a cosmic species. Our descendants may walk beneath alien suns, breathe alien air, or swim in oceans under distant moons. And as they travel, they will confront the same question that has haunted us for millennia. What is our place in all of this? Perhaps the answer lies not in finding life, but in understanding what it means to be alive in a universe so vast. Perhaps the purpose of intelligence is to explore, to learn, to shape the cosmos in return. We are the children of stars, but we are also their future. Our curiosity may be the force that allows the universe to know itself. And maybe, just maybe, when we finally uncover the deepest truths of existence, we will realize something profound. The universe was never silent. It has been speaking to us in the language of light, gravity, and time. It has been whispering through the motion of galaxies, the shimmer of nebulae, the pulse of stars. It has been waiting for us to listen. Now, at last, we are learning how. The cosmos is not empty. It is not cold. It is not indifferent. It is a stage of endless creation, a boundless sea of mysteries, a story still being written. And you, yes, you are part of it. Your atoms, your thoughts, your questions, all of them are pieces of a grand cosmic puzzle. And as long as humanity keeps looking up, keeps asking, keeps reaching, the story will continue. Because the greatest truth of all is this: the universe is full of mysteries, and the greatest mystery is that we are here to witness them.